Good afternoon and welcome to the group exhibit Hydrogen and Fuel Cells at Hanover Fair 2012. Please join me. Please do come in. Drinks are on the house. Seats are relatively comfortable. The talk that we're going to have now are hydrogen on-site trials from ITM Power in the UK. With me I have Steve Hallett, who's an applications engineer. Please join me in welcoming him on stage. Welcome.
Hi, how are you doing?
Good, yourself?
Yeah, very well, thank you. Very well, very well.
I suppose a good place to start is what does HOST stand for?
Well, the hydrogen on-site trials, or HOST, was dreamt up about a year and a half ago, and actually started in March of last year. And it was essentially the idea of delivering to a series of cross-sector industries a hydrogen refueling station and some vehicles, so that they could actually interact with hydrogen technologies that they wouldn't normally be able to use without signing a check for. So we started the project in March. We approached 22 different partners from 7 different industrial sectors, with the light of delivering a refueling station and some vehicles for them to try out. So
where have you taken this technology?
The refueling station and vehicles have been driven effectively the length and breadth of England. They've been as far south as the Isle of Wight. They've been across water. They've been transported to Scotland, and for those of you who are interested, it's actually positioned outside now. You can see it just by the end of the vehicle demonstration area, where we will be doing some live refuelings at 12 and 4 o'clock.
Which we are very proud to have, because it's the first time that you've actually had this outside of the UK.
Absolutely, and it's been a obviously certification process, and compliance is particularly important with pieces of equipment like this. The units have been obviously compliant within the UK, and we've been working with the TUV or TUV to bring the units here, and we're proud to say that it's been compliant and allowed to operate. So it's very good news.
Well, congratulations, and thank you for bringing it here first.
No problem.
For techies in the audience, what is the technology that's inside?
So ITM's core technology is electrolysis, proton exchange membrane electrolysis, and that's essentially the splitting of water through the combination of electricity and water. The outputs are hydrogen and oxygen. The oxygen we generally vent, but is of very, very high purity, so can be used in specific applications. And the hydrogen is compressed and stored, ready for dispensing to vehicles.
So other than events like this, what type of facilities do you visit, or have you visited?
Well, it's the HOST trials were really designed to try and target the area of the market that experiences return to depot fueling. So vehicles that operate on a very close radius or very close locale to a point of refueling, and this makes for an intelligent rollout of infrastructure and gets over that hurdle that is, well, I've got this hydrogen vehicle, but where can I refuel it? And so we approach companies, delivery companies, for instance. There was a good example, the likes of DHL, UPS. We also approach companies that have a slightly wider spread usage of vehicles, so guys who are driving 80 to 100 miles a day. And the limited range of the vehicles meant that perhaps they weren't so suitable in that situation, but we were still able to deliver a trial and demonstrate the use of hydrogen in applications like that.
Right, so you must have met all kinds of people from all different walks of life during this. Have you had any, what was the typical reaction?
Well, generally speaking, the reaction is very good. People are fairly overwhelmed by the fact that they can be using this technology now. We've had some guys who've refused to hand back the pieces of equipment that we've given them, and we've had some guys who've been completely unimpressed by it all. And I think probably the most interesting story was I gave the keys for the hydrogen vehicle over to a gentleman who was to be using it for doing some deliveries in and around Skelmersdale, and he he came back to me with the keys and he said, I don't want those keys. And I said, well, why don't you want those keys? And he said, well, I was expecting to be driving something really high tech, some rocket ship, something that didn't make any noise, that glowed blue in the dark, and you know, where the steering wheel, when you turned it left, didn't go left. And I said, well, it's an internal combustion engine vehicle, and the conversion is a fairly straightforward one. And so that's probably the most extreme reaction we've had, just this sort of this expression of underwhelming unexpectation, you know.
So really what you're saying is that we should apply blue LEDs to the outside of all the vehicles and we'd have greater acceptance.
Perhaps not that far, but yeah, certainly.
So other than meeting all kinds of interesting people, what kind of experience, what has this brought to your company?
Well, the outcomes of HOST, we've been able to do an analysis that obviously analysis that is very interesting to us of these different sectors and their usage of vehicles and where hydrogen can play a role. And from that, we're able to establish whether we can apply hydrogen technologies or the most intelligent way to roll out technologies to these different customers. On one example, you can look at captive fleets, manual handling equipment, things like that. And that is one extreme of the HOST trials. Essentially, that's where you have vehicles that never travel further than a few hundred meters from the refueling point. And the benefits in scenarios like that are rapid refueling and low plant use. At the other end of the scale, we've been able to do analysis of guys who are driving vehicles who want to try and target this big carbon footprint that comes from the use of fossil fuels, and giving them the ability to have a dual fuel vehicle that not only uses hydrogen for the first 80 to 120 miles, but then has the ability to also get it home by using gasoline. That sort of analysis is invaluable to a company such as us. The sort of results we've got, I mean, hydrogen, the H-Fuel refueling station is a 15 kilo a day refueling station, and we've generated over 500 kilos of hydrogen during the trials. We've traveled 10,000 kilometers in 2 vehicles, and we've never ever failed to refuel a vehicle. There's been 100% availability on the plant, and all of these different findings really goes to show that the technology that we're trying to provide is usable today, reliable, and it's robust, and it can work in the environments that you apply it to if they're well thought out.
So I can buy it then?
Yes, absolutely. Yeah, we're happy to deal with any customers who are interested in trying to address return to depot fleet fuel usage, or indeed captive fleet environments. We provide fueling solutions from 15 kilos a day up to 100 kilos a day and more if required. So if anybody's got any interest in products of that nature, then give us a call.
So that's fantastic that they have the ability to buy it. Now then the question becomes, should I buy it? So are there any situations that you find that it's extremely, so the fleet mentality, but are there any situations where you find it's economically favorable already to go with that type of solution?
Well, it's rather a difficult question. I mean, the one thing that we want to avoid as a company is selling hydrogen into scenarios where it's not going to be efficiently used, or where it's not going to be appropriate to use it. I think one of the worst things that happened to battery electric vehicles when they came about and were able to be sold was people were trying to use them for things that they weren't really designed to be used for. You know, expecting battery vehicles to do the 100-mile range every day, day in, day out, is rather a tough call. And so, you know, with hydrogen, you need to make sure that the entire energy system, and vehicles are part of an energy system, is suitable. And you know, the more and more efficient you can use the hydrogen, so if you move to fuel cell vehicles as opposed to internal combustion engine vehicles, the more and more economical and the more feasible the whole solution becomes. So, you know, using hydrogen in areas and very inefficient reconversion of hydrogen is the areas we tend to try to avoid. But other than that, you know, we can look at energy systems modeling from there upwards.
Can you give me an example of a situation it shouldn't be used for then?
Wow, difficult. I mean, hydrogen for domestic heat is very, very difficult. Domestic heat loads are very, very high. As a result, it's quite tough to use electrolysis and hydrogen procurement to solve those heat loads. There's no point in trying to throw high technology at fundamentally inefficient pieces of equipment. And it's those pieces of equipment, I'm not going to name and shame them, but those pieces of equipment that, that really you need to avoid.
Right, okay.
Yeah.
So you've managed to have very positive impacts with your program. Can you see this program being deployed elsewhere? Do you know of any initiatives that are trying to follow your lead?
Not as such. This is certainly a UK first. We are looking at moving host or the hydrogen on-site trials to Europe and to Germany. We can offer the sale of host trials to people where we will deploy a transportable refueling station. I think that's one thing that's quite unique about the proposition, is the fact that we are able to rapidly deploy, rapidly do the commissioning and decommission work to a site as long as there is water and electricity available. So yes, we are looking to roll that out to other partners if they're interested in that.
A bit of a European tour.
Yeah, absolutely. Yeah, Euro trip. Yeah.
Very nice. How long, just out of interest, because it's a very interesting form factor. It can be used on a regular container shape, so it's very transportable. How long does it take you to set up when you pull up to a site?
Well, typically, when we started the trials, obviously there's a pretty steep learning curve to get up. But when we started the trials, it was taking us about 2 days to get it up and running. That is upon placement of the unit on site and then connection to utilities. Now we can commission a site within 6 hours, ready for operation for as long as necessary, and we can decommission within 2 or 3 hours.
That's pretty good.
Pretty quick.
You've got a lot of practice, I
yes,
guess.
absolutely, too much.
We have a little bit more time. Are there any questions from the audience before we continue? Right. Well, feel free to put up your hand at any time to interrupt me. I do have a question. You have more products than just the mobile station. Can you talk a little bit about the other products you have available?
Yeah, sure. I mean, we have developed electrolyzers from very, very small benchtop desktop units all the way up to very, very large scale electrolysis that can be used for vehicle refueling. We have, as a result of building effectively a membrane electrode assembly and sort of building that into a stack, we found that the more and more the stack, whilst the stack is an important piece of the puzzle that is an electrolyzer, it's actually the system that's the most important thing. So we can deliver full products from 3 litre a minute units up to 5 kilo a day, 10 kilo a day, 15 kilo a day modular units. 25 kilo a day high pressure electrolysis, and electrolyzers that are particularly well suited to being directly coupled to renewable energies. We have one totally off-grid solution that is called HBox Solar, and that connects to a PV panel of around the 1.3 kilowatt size. And that won't need a grid connection in order to be able to generate hydrogen. And the reason is that it's got a particularly a unique form of producing the hydrogen. It's a unique stack design that we call the passive electrolyzer, and it has a very, very low balance of plant load. So the passive electrolyzer, typically it's a 1 kilowatt unit, typically has about a 5 watt parasitic load to run the balance of plant. And that 5 watts is 0.5% if you look at it in efficiency terms. And that means that as the sun comes up in the morning, it can start generating hydrogen almost immediately, whereas pumped systems that require pumps to be running, control systems to run, and solenoids to actuate require to effectively have to wait for a threshold before they can turn on. And that's a particularly unique product, and that's something that we're particularly proud of being able to do.
So is this your own technology, the passive approach?
Yeah, it's our technology.
And it does look really interesting if you go by. It's a completely different shape and form factor that you're used to seeing when you're looking at a fuel cell system. So you would offer complete systems to renewable. So if you had a solar farm.
And as I said earlier, we started at the stack level, and we ended up getting involved in building balance of plant units and bolt-in balance of plant solutions. And from there, we've got more and more involved in every aspect of the hydrogen systems that we get involved with. We've gone as far as building vehicles, converting vehicles to hydrogen. We've designed whole energy systems with renewable technologies. technologies, and we sort of play in the whole space that is operated by hydrogen energy systems. We've used battery technologies as well, so we've got the capabilities and we've got the brains within ITM to be able to offer solutions to most applications.
So you're interested in designing custom systems, for example?
Most of the work we do nowadays is bespoke. Whilst we try to make everything as modular as possible, typically there's a requirement to have something that's specific to a particular application. So we do a lot of bespoke work as well.
Can you give me an example of an application where you use your passive system, for example?
Well, I mean, one application that's particularly interesting for passive electrolysis is telecoms communications. By their nature, telecoms towers have to be remote. They have to be in the top of hills, and there isn't always a power supply there. And the connection costs for those pieces of equipment to power supplies can be quite substantial. So a lot of the telecoms companies are looking at the ability to, instead of connecting to a power source that's maybe 1 or 2 kilometers away, instead of doing that, trying to generate electricity renewably and then use energy storage systems such as batteries and hydrogen technologies to make sure that they've got a stable supply for all of their telecoms equipment. So that's a particular application for passive technologies anyway.
So it's actually cheaper to produce it themselves on site than to run a cable?
Yes, in quite a lot of the cases. I mean, a telecoms tower, certainly in the UK, may range from 600 watts steady load to sort of 1.5 kilowatts. So very, very low loads. To make that connection over a kilometre or so can be very, very costly, and they know that they can satisfy that with renewable technologies. So that's a particular application we're very much interested in.
It's a very interesting application when you have DC power already, don't even need to convert it.
Exactly, yeah.
And store it, run it back.
Yeah, yeah, and there's space for hydrogen to play there because I mean, battery technologies, we can't do them any misjustice. They're tremendously well tested, and hydrogen as a component within that system can perform a very, very small aspect and just essentially prevent very, very deep discharge of those batteries. Or it can play a much larger role where it essentially caters for all of the energy requirements of the system and has a very, very small battery. So the space for hydrogen to play in there is quite varied and quite large. So that's why it's such an interesting application for us.
Well, thank you very much.
No problem.
Any other questions before we finish? Well, please do. We're very, very honored
Thank you.
that the first time you come outside the UK, you chose to bring your unit here, that we get to try it out. What times again were those that you're doing the demonstrations?
We'll be doing the demonstrations personally. I'll be doing them at 12 and 4 o'clock.
Well, so I hope you have nice weather for that.
Yeah, fingers crossed, yeah. And we'll actually be refueling the NRW fuel cell bus that is also doing laps at the moment. So, so it shows that we can refuel big stuff as well as small stuff.
Great, so you get to take a ride as well.
Yeah.
So please do also, for example, the passive fuel cell or passive electrolyzer that we were talking about is available to see at the booth. That's B60, just over there. They have other products as well, and they'd be happy to talk to you. Please join me in thanking Steve in his talk today for joining us.
Thank you very much. Cheers. Thank you very much. Yeah. Okay, lovely to meet you. Cheers. Thank you very much.
Please do stick around. The next talk that we have, just coming up in a few minutes, is from Valent. We have Alexander Downsteiner, and they'll talk about Valent fuel cell heating appliance demonstration successfully started. Thank you.